Okay, we have here sample 1 for lateral earth pressure. So the figure shows a retaining wall that is restrained from yielding. So we have pressure at rest. We have to determine the magnitude of the lateral earth pressure per unit of wall. Also, we have to calculate the location of the resultants D measured from the bottom of the wall. So the given retaining wall has a length of 7 meter. And we have here a cohesion of 0. Hence, we have a backfill of soil. We also have here a unit weight that is equal to 17 kilonewton per meter cube. And our angle of internal friction is equal to 38 degrees. We also have here the consolidation ratio, which is equal to 2.5. So in our problem, there's no given location of water table. So we assume that our unit weight of our backfill is in dry condition. So for us to determine our forces, it will be easier for us to calculate its corresponding values if we have to draw our pressure diagram. Okay, so okay. So in this case, our pressure here at our ground surface will be equal to 0 since wala tayong uh, additional load in here. So yung pressure natin dito at x is equal to 0 or at h is equal to 0 is equal 0 pa rin siya yung pressure natin. And increasing with the depth of our soil, which is the 7 meter. So, okay. That will be our pressure distribution for this particular problem. So the resultant of this pressure diagram is at the centroid of our pressure diagram. So let's say that is P. And our location of our resultant measured from the bottom is h over 3 over of the height. That is the resultant that is located from the bottom of our wall. And then the distribution will be increasing as the depth increases, since if you remember, pressure is equal to the unit weight times the height. So the pressure at the ground surface will be equal to 0, and as the depth increases, our pressure also increases. Okay? So first, to solve this is we need to solve for the value of our K, our pressure coefficient. So this is restrained. So naka-restrain yung ating uh, retaining wall. So rigid yung retaining wall natin. So our K here, we have here OCR given siya. So our K, yung lateral earth pressure coefficient natin for rigid is equal to 1 minus sine of our internal friction OCR times sine of phi. So yan yung magiging pressure coefficient natin if we have a rigid retaining wall. So substituting the values here, we have KO that is equal to 1 minus sine of 38 that is given in our problem. We also have given OCR, which is 2.5 raised to sine of 38. And so calculating our value for lateral earth pressure coefficient for rigid retaining wall is equal to 0.6756. So kindly check if my calculation is correct. Okay, we have now our lateral earth pressure coefficient, which is equal to 0.6756. Okay, so our pressure now, let's solve for our pressure. That is pressure at H is equal to 0. Our pressure at 0 is equal to 0. So at H, this is our H, yung height natin. At H is 7 meter. Our pressure at 7 meter is equal to the unit weight times the height. And so, our unit weight is equal to, or you can multiply our coefficient, our pressure coefficient, yung KO. So, that is equal to, so yung value natin dito, our pressure here is K gamma H. So, that is equal to K. Our K is 0.6756. Our unit weight is 17 kilonewton meter cube. Where H is equal to 7 meter. So calculating our pressure at 7 meter, our value here is equal to 80.396. So our unit here is kilonewton meter squared. That is our pressure at 7 meter. Okay, so now we can now solve for our magnitude of lateral earth pressure per unit of wall. So our magnitude we have here. We have this value. So ito yung magiging resultant pressure natin. So our PO here, or the magnitude, this one, of our lateral earth pressure per unit of wall is equal to the area of this triangle. Okay, so the area of the triangle is equal to 1/2 the value here times the height. Okay, so our PO here is equal to the 1/2. Our value here, which is our pressure at 7 meter, times the height, which is 7 meters. So substituting our value here, 1/2 of 80.396 kilonewton meter squared times our height 7 meter. Okay, so we have here now our value of PO that is equal to 281.55 kilonewton meter. So this will be now our magnitude of lateral earth pressure per unit of our wall. So that is kilonewton per meter. And then we also have here to calculate the location of the resultants they measured from the bottom. So we need to calculate this value that is equal to Z. So our Z here now is equal to the location of Z of PO is now equal to 1/3 of our height. So, the location D is equal to 1/3 of 7 meter. Yung makukuha natin dyan is equal to 2.33 meter. So, that will be now our location of our resultant measured from the bottom. That is equal to 2.33 meter. Okay?